This is section 3.6, derivatives of logarithmic functions. So to start by, the derivative of log with the base b and the variable x will be 1 over this x multiplied by len of the base, and the derivative of len of x is going to be 1 over this x. Let's have a look at some examples where we will use them. Let's have a look at this example. Here we have to differentiate y equal to len x cubed plus 1. So here we might consider it as a composite function. We might consider g of x to be x cubed plus 1, and its derivative is going to be 3x squared, and we will consider f of g of x to be the y, which is len at x cubed plus 1. So in fact, to find y prime, we will multiply f prime at g of x and then find the derivative of g of x. So this is the chain rule method in fact. Now the derivative of len at g of x, we know it's going to be 1 over x cubed plus 1, because len of x, its derivative is going to be 1 over x. Now f prime at g of x is going to be 1 over x cubed plus 1. Now to write this down, y prime is going to be 3x squared multiplied by 1 over x cubed plus 1, and this can be written as 3x squared over x cubed plus 1. Let's have a look at this example. Here we have to find the derivative of len of sine of x. So we can say that y is len sine of x. As in the previous example, we might consider this as a composite function, and then we differentiate it using chain rule. So we might consider g of x to be sine of x, and f at g of x is the y, which is len at sine of x. So to find y prime, we know it will be f prime at g of x multiplied by g prime of x. So this is using chain rule method. So now g prime of x is going to be cosine of x, and f prime at g of x, it's going to be 1 over sine of x. Now y prime is going to be cosine of x multiplied by 1 over sine of x. So this can be written as cosine of x over sine of x, which will give us in fact cotan of x. Let's have a look at this example. Here we have to differentiate the function square root of len of x. So this can be written as len of x power 1 over 2. In fact, here we have a power. We might consider the power rule combined with the chain rule method. So our f prime at x is going to be 1 over 2 multiplied by len of x power negative 1 over 2 multiplied by the derivative of this. So it will be 1 over x. So this can be written as 1 over 2x square root of len of x. Let's have a look at this example. Here we have to differentiate this function, logarithmic function at the base 10 with 2 plus sine x. So here we might consider this as g of x and then use maybe the chain rule. So g of x is going to be 2 plus sine of x, and let's call it h. H at g of x is going to be logarithm with the base 10 at the g of x, which is 2 plus sine of x. So our f prime at x is going to be h prime at g of x multiplied by g prime of x. Now to find the derivative of g, it's going to be, so sine of x, its derivative is going to be cosine of x, and h prime at g of x is going to be, as we have seen earlier, the derivative of this is going to be 1 over 2 plus sine of x multiplied by len of the base, which is 10. So f prime of x is going to be cosine of x multiplied by 1 over 2 plus sine x multiplied by len of 10. and this can be written as cosine of x over 2 plus sine x multiplied by ln 10. Here we have some steps to do logarithmic differentiation. So we can use these steps whenever we have a function that is somehow hard to differentiate and can get easier using the logarithmic properties. So here the first step is to take natural logarithms of both sides of an equation, and then we use the laws of logarithms to simplify. Now then we differentiate implicitly. So we have done this in section 3.5, which is to differentiate implicitly with respect to x, and then we solve the resulting equation for y prime. Let's have a look at this example where we have to differentiate this quotient form, including the multiplication of these expressions, and this one has a power, so here we'll have power rule with chain rule, combined theorem. So I think it's gonna be somehow long to do it, but to simplify this we can use the logarithmic differentiation, which is to start by taking ln for both sides. So this is what we will get. Ln of y equals to ln of this expression x power 3 over 4 square root of x squared plus 1 over 3x plus 2 power 5. Now using the logarithmic properties, we know that this will become the difference of them. So this will be ln of y equals to ln of x power 3 over 4 multiplied by x squared plus 1 minus ln of this denominator, which is 3x plus 2 power 5. Completing with the properties of logarithmic functions, so this can be also separated. This will become ln of x power 3 over 4 plus ln square root of x squared plus 1 minus 5 ln of 3x plus 2. So just taking this power down, as we have learned in the properties of logarithmic functions. And also we can simplify more. This will be 3 over 4 ln of x plus 1 over 2 ln of x squared plus 1 minus 5 ln of 3x plus 2. Now we will differentiate implicitly both sides. So ln of y, this will be y prime over y equals to, here we have 3 over 4 ln of x, so this will be 3 over 4 multiplied by 1 over x plus 1 over 2 multiplied by 2x over x squared plus 1, because this is the derivative of ln x squared plus 1. Now minus 5, and here we have 3 over 3x plus 2. So this is the expression we get, and here we can do some simplifications. Y prime over y will be 3 over 4x plus this can be cancelled with this, and this will be x over x squared plus 1 minus 15 over 3x plus 2. Now to solve for y prime, we might multiply both sides by y, and this is what we will get. So this will be cancelled with this, and then y prime is going to be 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2, all multiplied by y. And here we have the power rule. Basically this rule we have seen it before in the chain rule section. So this says that if n is any real number and the function is x power n, then its derivative is going to be n multiplied by x power n minus 1. So this rule might be applied while we're differentiating. Let's differentiate this function right here. So here also it's better if we use the logarithmic differentiation. So if we take the ln of both sides, it will be ln y ln of x power square root of x, and this can be written as ln of y equals to the square root of x ln of x, because this was the power. Now if we want to differentiate both sides, here we can see that there should be a product rule. So the derivative of square root of x is going to be 1 over 2 square root of x, and the derivative of ln of x is going to be 1 over x. Now, differentiating both sides implicitly will give us y prime over y equals to 1 over 2 square root of x multiplied by ln of x plus 1 over x multiplied by square root of x. And this can be simplified in this way, so we can take y to the other side, and this will be y multiplied by ln of x over 2 square root of x plus 1 over square root of x, because here we have square root of x over x is going to be 1 over square root of x. And this is the answer.